While we were running the IR spectrum on our Diels Alder product, the GCMS spec finished its work, and you can see that there are 3 peaks. I angle the camera again. I think you can see that there are 3 peaks, one coming off very rapidly, and then between 3 and 4, and then another peak between 7 and 8. So that's rather an interesting result, given that we thought the solid that we isolated was pure. So we're going to go to the post-run analysis software. And I will have to open and close that file again. And we're going to open the Diels Alder product round 2. Well, Diels Alder product round 1, right, had nothing in it. So we're going to open that Diels Alder product round 2 file. It has integrated only that peak, but that's because we have the program set to turn the integrator off at time 0 and on again at time 7. So I'm going to delete all of that, assuming it will let me. So we'll just leave the integrator on for the whole time. This is much higher than it needs to be, but it's fine. So when I do that, now you'll see that it actually picks up all 3 of those peaks. And they're red, which means that the detector is saturated. There's so much compound in there, so it's a concentrated sample. And that's why we're not able to tell what the relative heights of those peaks are, because there's so much of them that they're all kind of off scale. And we've got this other peak down here, and it's just way off scale. So if I wanted a better analysis, I would need to rerun that sample, and I would need to rerun that sample at a lower concentration so that we could get a better looking set of data. And I'll probably actually do that. So what we're looking at here is, maybe that 97 peak is real, maybe not. It may just be that these peaks are so far off scale. So I'm going to go to the qualitative table, and I'm going to take those peaks and register them to the spectrum process table. And then I'm going to go to the spectrum process table and do a similarity search on the whole table and see what it picks up. And it thinks that first peak is dichloroacetic acid, which is very unlikely, and it's got some really interesting choices. None of those are likely to be true. And I think if we put ourselves on that peak and do our similarity search directly on that peak, we'll find it's really only a 67% match. That's a really poor match. It is not that compound. Right. Similarly here, if we, whoops, wrong button, do a similarity search, 68% match is the best. That's not a good enough match to be anything. And this thing that it thinks is dichloroacetic acid is only a 68% match. So it's not matching anything closely, and that's probably because the peaks are so far off scale that we're not getting accurate readings here. So I'm going to save that data file, but it's not likely to be good data. So what we really need to do, this is a good method. The compounds are coming off nicely in that time. I even can stop. I don't need the region from 9 to 11 minutes. So I can change that and have that at a 4-minute hold time and make this a 9-minute total run without losing anything. But I do need to keep that lower temperature to catch this peak. So that's good. I'm going to save the method file. Oh, I'm going to forget that I need to reset the mass spec to end at 9 minutes as well, because obviously it can't collect mass spec data if the GC is no longer running. Now I'm going to save that method file. And I'm going to go back to sample login, and I'm going to make 56R-4. This will be round 3. And 0.1 microliter, but I'm going to have to dilute that sample. So what I'm going to do, before I click the other button, is I'm going to take this over to the lab, and it just shows you how sensitive the GC mass spec instrument is, because that wasn't a very concentrated solution to begin with, but apparently way too concentrated for the GC mass spec, even at only 0.1 microliter. So we'll get some dichloromethane. And we will simply remove the majority of that sample. To the waste, leaving just a couple of drops in the bottom. So that's maybe 1/4 of a milliliter or so. And then we'll refill that vial with fresh dichloromethane. Fill it all the way up. And then we can set that sample to run again, and download our parameters, and we'll let it go, and hopefully keep things on scale this time.